Alrighty. Good morning. Welcome back. I hope you guys had a wonderful rest of your day yesterday after class. And that you had a wonderful morning so far. First period went well. All those things. Today we're going to be doing our practice activity in Desmos today for section 8.2 on estimating a population proportion. So we're going to get going with that. Just a moment. I'm going to drop the link in the chat for you. Yeah. All right, so in the chat, there's a link to the Desmos activity. Once again, please make sure you are logged in with your school email for your name to pop up properly and all that fun stuff. Once you get into the activity, please go ahead and do the first slide there on how are you feeling today. Give me a quick check-in, how you're doing, and we will get started shortly. You can also go to student.desmos.com and find the activity in our class page on Desmos. It is for 8.2. So, did that wrong. That's what I want to do. Sorry, click the wrong button. All right, we're able to go into the next frame here, guys. So if you want to move into page numero dos. This is just a quick review of some of the main things from section 8.2 that we learned yesterday. All right. I apologize that they're small. I don't know how to make Desmos make pictures bigger. I'm sure there's a way, I just don't know how yet. But these are kind of 4 things that are important to this section, right? We have our conditions for constructing a confidence interval about a proportion, random 10% and large counts. We have a 4-step process for doing confidence intervals: state, plan, do, and conclude. We have our 1 sample Z interval for a population proportion. This is an inference method, right? We learned yesterday, right? The confidence interval allows us to make an inference about the population, so it's considered an inference method. Right? And this method is based on a single sample. Right? And the interval is called a Z interval because it's between those 2 Z star values. And we have a sample size for a desired margin of error. All right. You will need these formulas today. All right. I do recommend that you have your notes from yesterday and that you have something to write on. All right, and to write with. All right. You will need to do like some scratch work to do some of the problems that we're doing today. You're going to want to be able to write out your work and to make sense of the problems. All right, so again, I do recommend you have something to write with. All right, so the first couple problems we're going to do, the first 4 problems we're going to do here today are multiple choice. We're going to do them in 2 chunks of 2. So we're going to jump to the first 2 multiple choice questions. I'm going to open those up. If you are following along on the shared screen, excellent. If not, and you're looking at your own Desmos activity screen, that's totally fine. I'm going to be talking about multiple choice 1 first, and then multiple choice 2, and then I'm going to give you guys some time to work on it. So multiple choice 1, a Gallup poll found that 28% of American adults expect to inherit money or valuable possessions from a relative. The poll's margin of error was plus or minus 3 percentage points at a 95% confidence level. This means that, you got to finish the sentence, one of the 5 statements below is correct. The other 4 are not. You need to try and do your best to pick the one that best interprets what this margin of error and confidence interval represent. Okay, so that will be multiple choice 1. Multiple choice 2. Most people can roll their tongues, but many can't. The ability to roll the tongue is genetically determined. Suppose we are interested in determining what proportion of students can roll their tongues. We test an SRS of 400 students and find that 317 can roll their tongues. The margin of error for a 95% confidence interval for the true proportion of tongue rollers among students is closest to, and you need to decide. All right. This you should use one of our calculations for. All right. We should be calculating the margin of error. So if we're looking back at our second page here, right, the margin of error, right, is the z star times square root of p hat times 1 minus p hat divided by n. That calculates margin of error. Right, so you will need to do some calculation to estimate which one of these is the closest. The good news is, majority of the people who answered both of the multiple choice questions answered it correctly. So this is an excellent place to start. If you'd like to follow along with what we're going to review next, please look at the shared screen or just make sure you're on the right page of the Desmos activity. Right, if we're looking at the multiple choice question 1, right, the correct statement, right, was that the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. Okay, that would be the correct meaning of the margin of error and confidence interval in this context. Right? Because again, they're referring to the confidence level. When we're talking about confidence level, that means that if we repeated this sampling over and over again, right, about 95% of our samples would result in an interval that captures the true proportion, right? And the method used says that we're within 3%. Right, that interval lands us somewhere within 3% of the true proportion. Right, the other options are incorrect interpretations. Right, remember when we're talking about confidence level or confidence interval, we're not talking about the probability. It's not a 95% chance. All right. Is there anything I can clarify about this first question? Okay. So now the second question. All right. Most people can roll their tongues, yada, 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 yada. The good thing is on this one, we actually have the value of p hat, right? The sample proportion, we have 317 out of 400, right? We know the sample size. The margin of error is what we're trying to find within a 95% confidence interval, right? The value here that's closest to the margin of error is the 0.04. And we have the work for this here. Ooh. Got much larger than I wanted. All right, so again, we have p hat. If you're looking at the shared screen, you can follow along with what I'm talking about. P hat was 317 over 400, we get 0.7925. The sample size n was 400. Z star, our critical value, is 1.96 for a 95% confidence interval. We saw this yesterday, right? We saw that 1.96 is a better approximation for that 95% center area of our normal curve than 2. And we know that the margin of error is equal to z star times the square root of p hat times 1 minus p hat over n, right? Critical value times standard error. We replace our values, 1.96, square root of 0.7925 times 2.2075 over 400, we get about 3.036. So the closest value is 0.04. Is there anything I can clarify for the second multiple choice question? Any questions? And again, I want you guys to notice how I'm setting up my problems before I do the work. I'm listing my variables. What do I know? What am I looking for? I show the formula I'm going to use, right? In its general form, I'm just using the variables in the formula, then I replace it with the values and solve. This is a strategy that I like to use. It helps me stay organized, right? So just an offer. All right. So then we're going to move on to our next two multiple choice questions. Both of these will involve needing to do some calculations. So please make sure your scratch paper is ready. All right. The third multiple choice questions. Right? You want to design a study to estimate the proportion of students at your school who agree with the statement, the student government is an effective organization for expressing the needs of students to the administration. You will use a 95% confidence interval, and you would like the margin of error to be 0.05 or less. The minimum sample size required is, we need to find that. So again, if we're looking back at our second frame here, we're using this formula, the fourth thing here, sample size for desired margin of error. You will need to determine Z star, right? We need a P hat, which we don't have. We don't have a sample proportion. So think back to look back at your notes. What do we do if we don't have a sample proportion to use? And we need to solve this equation for N. Right, question 4, newspaper reporter asked an SRS of 100 residents in a large city for their opinion on the mayor's job performance. Using the results from the sample, the C% confidence interval for the proportion of all residents in the city who approve the mayor's job performance is 0.565 to 0.695. What is the value of C? So we're trying to find out what's the percent confidence interval. Again, this one's going to take some working. You're going to have to kind of work backwards in a way to get to the that percentage. Okay. So we're going to work on these next two multiple choice questions. You will need to do some work with the formulas. Okay, so let's look at multiple choice 3. So if you're following along on the shared screen, please look at the shared screen. If you're just following along on your own Desmos activity, we're on slide 5 or screen 5. Right, we're designing the study. We want to use a 95% confidence interval, and I would like a margin of error to be 0.05 or less. The minimum sample size required is 385. Right, that is the minimum sample size. Okay, and the work for that is right here. So again, if you want to see the work that goes behind this problem, please look at the shared screen. All right, we have one note up over here. So in this scenario, we don't have a sample proportion to use. Right? We don't have a previous study. We didn't take a small sample to start. So our guess for P hat will be 0.5. Remember, we have the two options. We can use previous results or some sort of estimate based on what we know, or we use 0.5 for our guess for P hat. Right, so we're going to use 0.5. The margin of error that we want is 0.05. Right, so I'm listing the things that I'm going to use to start. The Z star, the critical value is 1.96 for a 95% confidence interval. The formula I have for margin of error is Z star times the standard error, square root of P hat times 1 minus P hat over N. It's less than or equal to margin of error. I'm going to choose to rewrite that so that I'm already ready to solve for N when I put in all my data. You do not have to do that. It's just the way that I like to do it. So we get n is greater than or equal to z star times square root of p hat times 1 minus p hat all over margin of error, that entire thing squared. We substitute in all of our values. We get n is greater than or equal to 1.96 times the square root of 0.5 times 0.5 divided by 0.05 squared, and we get 384.16, which means n is greater than or equal to 384.16. Because we have greater than or equal to, we cannot round down. We have to round up to 385. So our minimum sample size is 385. What can I clarify about this problem and the math that I just showed? What questions do you have? If you guys are looking at this and you're thinking to yourself, Mosley's writing in Chinese, you need to ask a question. Get clarification.
Can you go over how to find the z-score?
The z-star? Yeah.
Yeah.
Absolutely. So z-star is very similar to the z-score, right? When we're finding the z-star for 95% confidence, essentially what we're doing, I'm gonna open this up and we're gonna, don't pay attention to the markings on here, I need to erase them. They're for something else. Here's my table A. When we're finding z-star, we're almost always going to use the negative side of table A, right? Our negative z-scores, right? And that's because they give us that left-hand tail, right? The z-star is related to the tails of our standard normal curve, right? So on our table A here, if I'm looking for 95% confidence, right? That leaves 5% for the tails of my distribution, of my standard normal curve, because the confidence captures that center 95%, right? That's where my interval is. So the other 5% is outside my interval, right? And that's the area of the tails. So 5% is split on the tails. So that means we get 2.5% for each tail. We split that evenly, right? Because this is symmetric. We're right in the middle with the 95%. We have 2.5, 2.5. And that equals 0.025. So that means we go to table A and say, well, I need to find 0.025 on the interior of table A. So I go in here and I'm looking for 0.025, and I get it right here. This is one of the rare cases where we actually get exactly the value we're looking for, 0.025. Now that I found it, I trace back to the left margin and up to that top row. Those two numbers together give me the z-score associated with that proportion. We get z equals negative 1.96. Z star, our critical value, is the positive value of that z-score. Z star will always be positive. because z star is a distance. Okay, so that's how we get z star. It says I'm 1.96 critical values in this scenario. When we're dealing with a sample in a sampling distribution, we're dealing with the standard error, which is the standard deviation of the statistic. So these things are all connected. We're kind of taking all the things that we have used and renaming them for a sample because we're not dealing with the population anymore.
Okay, thank you.
Is there anything else I can clarify about this question? So then if we look at question number 4, right, what's the value of C? What is the percentage of confidence that I have for my interval here? And in this scenario, we get the closest one is 82. Now this one involves a little bit more legwork, although it is good to say on both of these questions, a majority of the students who answered it got it correct. So that's very good for me to see. I also noticed a lot of you guys going back to screen 2 to look at the formulas, I assume. So that's excellent as well. So for this question, I'm starting by listing what I know. My C% confidence interval is from 0.565 to 0.695. My sample size N is 100. I do not know Z star yet because I don't have the confidence interval or the percentage of confidence. But I can figure out p hat because I know what the interval is, right? P hat is the midpoint between my two endpoints on my interval. So I take 0.565 plus 0.695 and divide it by 2. I get 0.63. So that is my sample proportion. And now have p hat. From that, I can calculate the margin of error. And this is because we have our the regular kind of formula we're dealing with is our statistic plus or minus critical value right, which is Z star times standard deviation of the statistic. All right, our statistic p hat plus or minus Z star. Standard deviation of the statistic is the standard error. Right. This whole thing on to the right of my plus or minus represents the margin of error. Right? So essentially I can rearrange that p hat, right? This sorry, what am I getting? Oh yeah. Sorry, I'm finding the margin of error. Yeah, margin of error, right? Because I know that when I add or subtract my margin of error, I get 0.565, right? So when I subtract 0.565 from p hat, I get the value of this thing, margin of error. This is good. Now I can move forward more. I have margin of error, I have p hat. I know that margin of error is equal to Z star times my standard error. I can now solve for Z star. 0.065 equals Z star times square root of 0.63 times 0.37 divided by 100. Z star is this mess of division, 0.065 divided by the square root of 0.63 times 0.37 divided by 100, we get 1.35. This is now what I need to find using the negative version of z star on table A. We need to find this z-score negative 1.35. Right, this gives me the proportion less than negative 1.35 on the standard normal curve, which is my left-hand tail. And we get that that is 0.0885. Right, let me see. Right, negative 1.35. And we follow this guy down. We follow over 0.0885. That then, because that's only one tail, and I need to account for both tails, multiply that by 2, get 0.177. Subtract that from 100%, or 1, and I get 0.823. So C is closest to 0.8 to 82 as far as a percentage is concerned. Is there anything I can clarify on this mess of mathematics I have here on the page? What can I clarify? Again, I'm using the known formulas here. Go ahead,
So
Jose.
when you get the z-score and then multiply by 2, you're doing that because there's 2 tails, right?
Correct.
So that's to the 0.177. So then you subtract that from the 100% or 1, and then that'll give you confidence thing, the C. Yeah,
because in this scenario, I'm working from an interval back to what percentage of confidence that interval is, right? What percent of confidence do I have for that interval? So there's a lot of legwork going on, but I know that that confidence percentage is the middle percentage of my distribution, which means I have a section of tail to the left and a section of tail to the right. I can only find the proportion to the left of one tail, right? The area for one tail using table A. So then I double it because I have to account for 2 tails, and they have the same area. And then subtracting that from 1 gives us the center part, which is our confidence percentage. So yes, you are correct. What else can I clarify? Excellent. Thank you for your question, Jose. So now let's bump up to the next slide here. Right, a 93% confidence. Right, we want to find a z star for a 93% confidence interval using table A. We have a copy of table A here that you can scribble on. Right, you can find a value, circle it, right, trace it over. Good times. Right, so you can use this to kind of do the scribbling. Or you can use your own copy of table A if you have one available right now. I know that this is a little bit small. Again, I don't know how to make Desmos make these images bigger, though I wish I did. I need to figure it out. All right, so we're going to sketch on the copy of table A showing the proportion to the left of the z-score that corresponds with a 93% confidence interval. So again, this is using some of the same ideas that we just talked about on the previous example, right? What percentage of my distribution is left to split between the 2 tails, right? So for one tail, what percentage is that? What is that percentage as a decimal? Find that decimal on the interior of table A, trace it back to the left-hand column and the top row to get that z-score, and then convert that to z star by removing the negative sign. So that's our strategy here. I know that wasn't a lot of time, guys. but I do see that some of you guys are using table A to scribble on, so that's excellent. That's kind of what you got to do with table A. A couple of you guys have some responses. It even looks like someone used the inverse normal command on their calculator, which is excellent, good skill to have. The Z star value, or the critical value, right, should be 1.81. Right, that's the value we would find on table A. If you used your calculator and used inverse normal command, you should get something about 1.812. You'll get more decimal places, essentially. Table A only provides us up to a couple decimal places. Right? And here's how we get there. Right, so again, if you're looking at the shared screen, this is the math behind this. We start with 100%, we subtract the 93% from the middle. That leaves us with 0.07 or 7% to split between the two tails. We cut that in half, get 0.035 as the proportion or the area on the left-hand side tail. We find that in table A, 0.0351 is the closest we can get. Right? 0.0359 or 0.0344 are both much farther away than 0.035 than 0.0351, so we use that. We trace to negative 1.8 on the left-hand column and up to 0.01 on the top row, giving us a z-score of negative 1.81, which means z star is 1.81. Okay. So any questions on this example and the work that goes with it? Anything I can clarify or explain in more detail? So again, part of this is just getting more familiar with table A and how to use it. All right, so with that, we are actually going to stop here on the Desmos activity for today. I will open this up so you guys can look at the other questions that I have available, and you can practice with those if you like. Also, the practice problems for section 8.2 are available in Canvas. The solutions should be up later this week for that. And the practice problem, the example problems that we did yesterday in class, there's a copy of that available in the calendar in Canvas on my homepage, so you can look at that if you like. Yeah. Other than that, that's all that I have planned for you guys today. That's our practice problems. If you have any questions, feel free to stick around and ask, get some more clarification. Besides that, I will see you guys next week on Tuesday for section 8.3, where we'll be dealing with population means.